Hi. Altitude, remember, is a perpendicular that is dropped from a vertex to the opposite side. In this video, we're going to show that the three altitudes of a triangle are concurrent. So, in the last video, we showed that the three medians of a triangle are concurrent. And the concurrency point is called the centroid. Let's call the centroid G. We also know that if you take a triangle, then the perpendicular bisectors of the sides meet at a common point called the circumcenter. This is the center of the circle passing through the vertices of the triangle ABC. Now let's put all these three configurations together. And when we put them together, let's erase all the lines so that we can see the centers clearly. Now, we're going to show these three centers lie on a common line called the Euler line. Let's go. Okay, hi everyone. So I have with me a triangle ABC, which is circumscribed in a circle with center O. So first, let's locate the midpoint of BC. Alright, so the next thing we're going to do is join A and M. Now, when you join the vertex to the opposite midpoint, such a line inside a triangle is called a median. Okay, so we have already seen in the previous video that if you consider all the three medians, they meet at a common point called the centroid, right? This is your centroid G. Okay, so this centroid, as we have already shown, divides this median in the ratio 2:1. Extend OG to a point X so that OG is to GX is 1:2. If you join A to X, you see that triangle AGX and triangle MGO are in fact similar. The reason is we already know AG is to GM is 2:1. We have constructed X such that XG is to GO is also 2:1. And now we also know that these two vertically opposite angles are equal. So by SAS congruency, side angle side congruency, we have these two similar. But if they are similar, then corresponding angles must be equal. So angle A must equal angle M. So you must have this angle equal to this angle. Okay, so therefore we have AX parallel to OM. You might be wondering, how did we get that? This is the alternate angle. Notice the alternate angle condition. Saying these two angles are equal implies these two are parallel. Okay, so OM is parallel to AX, but remember OM is perpendicular to BC. And therefore we have AX perpendicular to BC. Now here's the beautiful thing. Whatever this point X was, since AX is perpendicular to BC, it means that X lies on the altitude dropped from A to BC. If you look at the perpendicular from A to BC, X lies on that. Now notice, we could have run this argument exactly on the other direction as well, right? I mean, what's so special about dropping A? I could have turned the whole picture and joined B to X and run the whole story. So what would that mean? I mean, if I had taken this midpoint, this B and so on, I would have put X lied on the perpendicular from B to BC. Okay, so symmetrically, so all the altitudes are concurrent. That's what we proved. Amazing conclusion. And this concurrency point at a point called the orthocenter. Three important points of a triangle: the circumcenter, the centroid, and the orthocenter. All three are collinear, and the centroid divides the line segment OH in the ratio 1:2. Okay, divides it in the ratio 1:2. So this special line in which all these three centers exist, all the three centers lie, is generally called the Euler line. Okay, so this is called the Euler line. named after Euler, who discovered that this happens, that the centroid, orthocenter, and the circumcenter are collinear.